Welcome to One Question at a Time, the TSI series. Question number 116. In the figures above, segment BC is 4 units long, segment CD is 8 units long, and the segment DE is 6 units long. What is the length of segment AC? So, first of all, we have to label all the given informations on the diagram. So we have BC is 4 units long. So let's write down 4 here. CD is 8. And then DE is 6 units. What is the length of segment AC? That is the question mark. So to solve for this problem, we need a lot of information. First of all, we see that we have two right triangles, which is mean the angle have the measurement of 90 degrees. So that angle B and angle D is the same. Also, we see the vertical angles AC, B, and we have the angles ECD that equal because it's the vertical angles. The angle opposite each other will be equal to each other. So here you see like the diagram here, we have part 4 and angle 4 and angle 2 is the same thing because it's vertical angle. I have the same measurement. Angle 1 and 3 are the same, so we can draw down angle 4 equal angle 2 and angle 1 that equal angle 3. Okay. So why we need that is because we look at two right triangle. Okay, we have two right triangle. We have right triangle A, B, C. Okay, and then we have to figure it out, is that congruency or similarity to the triangles E, D, C. So as we see the side, right, of the angle ABC is smaller than the angle EDC. By eyes, we can see that. So of course it's not the congruency, it's the similarity. Because it's the same shape, but it's different from the side. Or the dimensions is the multiple of ones, right? So similar triangles will have the same shape, but not necessary to be the same side. So congruency is exactly the same. Similarity can be congruency or can be different shape. I mean different dimension, but the same shape. It can be bigger or smaller with the same shape, with the same ratio. So corresponding angle are equals. That's the characteristic of the similar triangles. And corresponding sides are in the same ratio. So to test for similar triangle, we need two corresponding angle are equal. So angle case, this is the first case. The second case is you need the three corresponding sides are in the same ratio. And then the third one is the side angle side ratio of two pair of corresponding side are equal and their included angle are equal. Okay, so in this case we can use the angle, the first one, to saying triangle ABC is similar to triangle EDC. And also we need to be focused on the corresponding angles. So you see that the C is equal with angle C on this side. That's why they write out at the positions, the last one right here. Okay, the 90 degree angle is corresponding B to D. So you write B and D at the middle. And then the rest is A and E. Okay, so we have angle B that equal angle D. We have angle C on this side is ACB that equal angle ECD. Always have to write it correspondingly. So you see that A start and A with E. So A with E, B with D, and C is the same, right? So corresponding to the positions when we note it down. And of course, why we only need two angles is because the third one automatically will be the same. It's because the sum of all angles inside triangle is 180. Okay, so A plus B plus C that equal 180. And similar to E plus D plus C again. C inside of the triangle, okay? The right triangle. So we see that two angle C is the same. So we have D is 90 degrees the same as angle B. So of course angle A and angle E is the same measurement. Okay, so it's not necessary to be solved for the third angle. We only need two. So now we know that this is the similar triangles. So now we can use the corresponding sided are in the same ratio fact to solve for the problem. See that we have BC, you see right here is BC next to each other, right? So over the DC will be the same as AC. See that I use the small triangle on the top, the larger triangle at the bottom. So I keep that. Okay, keep that. On the top is the part of the small triangle. So I want to find the AC and the corresponding side to another, the bigger one is A go with E and C go with C, right? That equal to AB go with ED. And now just plug in to see how can we solve for this, right? So BC is 4 over DC is A. That equal AC over EC, that unknown, right? Equal AB, unknown, over DE is 6, or ED is 6. So we have this, we have BC, We have DC. And our target is AC. We want this one. So as we know, this one will be reduced to 1/2. Because we have 4 over 8. It's the same thing as 2 times 2 over 2 times 4. We reduce top and bottom by a factor of 2. Then we have 2 and 4. So this one still can write out as 2 times 1 over 2 times 2. Or if you kind of seeing this one is 4 equal 4 times 1 over 4 times 2, and then reduce the 4, that is 1/2 as well. We reduce again, so that will be 1/2. So we can solve for AB and then use the Pythagorean theorems. That's saying the hypotenuse that will be square equal the sum of the side square. Okay, so either you solve for the CE by the Pythagoreans, okay, then use the ratio to solve for AC. So we have two ways, okay. You can solve for CE. Let's say the first way you can solve for CE based on Pythagorean theorems. Then use the ratio one-half to solve. Okay, and this is right here. Then you will have here is AC is equal to BC times EC over DC. That is for way number 1. Okay. Now for number 2, I like it more because I just need to work with the small number. Okay, so I can find the AB. I can find the AB by the ratio. So the second weight we can do is we find the AB based on the ratio, and then we use the Pythagorean theorem to solve for the AC. So for myself, I like the second way because it will be shorter. I mean, not shorter, but it's easier because it carries small numbers and the familiar numbers I know. So for way number 2, we will find the AB. So we find the AB based on, let me highlight that part. Based on this one, BC over DC equal AB over ED. Okay, so we will have 1/2, the ratio 1/2 equal AB over 6. So AB will be equal 6 times 1 over 2, that is 3. So as you know, we have the right triangle with one leg is 3, another leg is 4, so the hypotenuse should be 5. Because that's a triangle 3, 4, 5. Okay, so B is the correct answer and I don't have to go further. But of course, it's so if you want to use the Pythagorean theorems, you can use it at AC squared that equal to AB squared plus BC squared. Okay, and then we have AC squared is equal to 3 squared plus 4 squared, and 9 plus 16 that equal 25. Now we have AC, we square root both sides, we have square root of 25 is 5. So AC equal 5. Okay, so how about if we do the first one? We have to work with the big numbers, right? But of course, it's not really afraid of it, because you see this one is 6 is A. It's just kind of like double, right? So right here, we have 4s go to 8. So 6 is 3 go to 6. So 5 will go to 10. This is should be 10. Okay, so let's do for CE. I will do it in colors dark blue. Okay, so if you find CE, you do square because that's the hypotenuse. That equals CD squared plus DE squared. And this is A squared plus 6 squared. A squared is 64 plus 6 squared is 36. That is 100. Then you take the square root both sides, so CE equal 10. Okay, so some people is really not good at remember or memorize the A squared, 6 squared. They have to do A times A, 6 times 6 to get the 64 and 36, right? Or it's kind of like bigger numbers make people work harder. So we try to work with the smaller numbers. That's why I choose the second way. So now we have the CE length. Now we use the ratio. Remember, we have the ratio. We do the BC right here. We use this one, AC equal BC. BC is, let's write that right here, AC equal BC is 4. Okay, that given. Multiply by EC, we just, EC is CE, we just find it equal 10. Then we divide by DC is 8. Okay, so you will have 4 over 8. Remember, we already do it right here is 1/2, right? So 4 is 4 times 1, 8 is 4 times 2. So we cross that, 10 divided by half is 5. So we have the same numbers. So B is the correct answer. So one more note here is always remember we have the right triangle ABC, right? Or right triangle with the measurements of 3, 4, 5. So if it multiple of those numbers, you will have the next one. For example, this one, we have the next one, they multiply by 2. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Okay, so you can have another one with the multiple of 3 for each side. So 3 times 3 is 9, 3 times 4 is 12, and then 3 times 5 is 15. So this one is kind of like the basic one, the most basic one to memorize. And that will helpful when you see some question like this. It helps you to solve it faster. But if you don't remember it, you can always use the Pythagorean theorems to solve for the side, and then you can use the ratio based on the similar triangles fact right here to solve our problem. It's a little bit long for this question, so hopefully it will be helpful. Thank you for your patience. Thank you for participating in this series, and see you next time.